So as Jim was introducing ABMI, I work at ABMI as well. I do a lot of the science behind the work that he was presenting. So I did my PhD at the University of Alberta, and I looked at the effects of climate change and grazing on rangeland. So a lot of my presentation today is going to be looking through the perspective or lens of rangeland or grassland conservation, because I'm interested in that ecosystem type, but certainly ecosystem services are applicable to any kind of habitat type that you are interested in. So, putting Alberta's ecosystem services on the map, focus on rangeland. I'm not sure how familiar you all are with the idea of ecosystem services, but I think this one comic depicts the idea of ecosystem services really well. They're basically services or benefits that nature provides for free for humans. And so here we have these guys, and they don't need to mow their lawn because they have sheep. Another great example, because Alberta is slowly integrating policy on ecosystem services, but it's not huge here yet. But a really well-known example is from a watershed in New York City, or affecting which New York City is in the center of this watershed, and the city was presented with a challenge where they had to increase the quality of their drinking water. And to build a wastewater treatment facility to handle the amount of water that was going to come through would be about $8 to $10 billion. So they did a big planning, assessment, etc., and they looked and said, well, if we conserve this watershed, which is upstream from our city and can purify the water just by merit of the wetlands and the type of species and habitats and soils that are there that are also capable of filtering water, if we can protect this land, it only costs $1.8 billion, and we will reap the same benefits as installing this treatment plan. So that's actually what New York ended up doing for their water filtration, which I think is a really neat example of ecosystem services at work. Rangeland provides a whole bunch of ecosystem services. Obviously, we're all familiar with the idea of forage production. This is one of the ecosystem services that rangeland provides that is already valued on the market, and people are making a living off of it, although I think most ranchers would say it would be nice if they could get some more benefit from their land than just the ranching, because prices aren't always comparable to crops, etc. But rangeland provides a whole bunch of other ecosystem services. So carbon storage, which I depict in this figure too, this figure here. And although here we have a picture of a tree, grasslands actually store a whole bunch of carbon, and that's because their soil is very rich with organic carbon, and then as well grasses have huge below ground root systems that store carbon as well. And so obviously this storage of carbon prevents it from going up into the atmosphere and feeding back into climate change. And carbon is a really neat ecosystem service because it's one that's actually valued on the marketplace. So right now in Alberta we've priced carbon at $15 per ton, but worldwide there are different prices for carbon, and it's one where if you're a rancher, you're in Red Deer, and your grassland is providing carbon storage, you're essentially providing that benefit to humans all around the world, not just people in Red Deer, because that carbon is prevented from reaching the atmosphere. Also, rangelands provide pollination, so they support bee habitat, and these bees can go out and pollinate adjacent canola fields, which is actually a service that rangelands are providing for free. They provide biodiversity, which is a little harder to put an economic value on, but which Jim just talked about is clearly really valuable to us as Albertans. And then along with biodiversity comes species at risk, and water filtration and water storage. So a little more on Alberta rangelands, because this grassland or native grassland was what was here before. A lot of it was converted into crops and whatnot, but we're actually lucky in Alberta because we have a lot of remaining habitat, and in the south of the province, that's grasslands remaining. So in some states in the US, they have less than 1% of their native grassland remaining. In Alberta, depends on the estimate, but it's somewhere around 20%. So we still have, not lots, but some of it left to decide how we're going to manage and what we're going to do with that land. So we're at a pretty pivotal point. And if rangelands are only valued for their beef production, you can see how continued conversion to canola or other kind of crop uses will happen. You know, we're not here to put any kind of judgment on a type of land use, but with the idea of ecosystem services, it's important to take into consideration all the kinds of benefits that that land might be providing, not just the kind that is currently valued on the market. So it's not just about how much native habitat is left, but there's also a component of what kind of condition it's in. So it's relatively unknown what the status of rangeland in Alberta is. Some estimates say that less than half of it is in good condition. So there's a potential to better manage rangelands to make sure that they're sustainably managed. And if there was an incentive for ranchers to do so, if they could reap some kind of economic benefit from having healthy rangelands, this might be more attainable. So it's great to talk about all this concept of ecosystem services and what we might do if we had this information and how we can incorporate it in planning. But at this point, we simply don't know what the value is of our ecosystem services in Alberta or where they are. So if we're looking at a map and someone said, can you map out pollination across Alberta? I don't think anyone in this room could do it, or even in a room of experts on pollination. And so that's really where our project at the ABMI is coming in, to fill this gap on ecosystem services knowledge. And I also want to point out here that grasslands are a particular habitat where there's less information on ecosystem services, and Canada actually has a lot less information than the United States. So it's very important and timely for this project to come along. So the goal of the project is to develop a system to assess and map ecosystem services across Alberta to better understand how planning and management decisions affect the landscape and increase benefits to Albertans. And we have a whole bunch of partners on this project. Our two main funders are ALMA, the Alberta Livestock and Meat Agency, and AI Bio, Alberta Innovates Biosolutions. But at ABMI, we're all about integrating resources and bringing people to the table if they have something to contribute. And so we've relied on a whole bunch of experts from other organizations as well to fill in gaps in this project. So ABMI is an expert on biodiversity, but we've been moving beyond biodiversity, especially with the help of these other organizations. So I'm going to stop here and play a video about our project because I think it tells our story really well, and it might steal a little bit of what I'm going to say in the next slides, but I think you guys will enjoy it. So.
Ecosystem services are benefits that humans receive from nature, which support our health and well-being. They come in many forms, like food, timber, clean water, recreational experiences, climate regulation, and pollination. We have a good understanding of healthy ecosystems in Alberta, but have limited knowledge about the valuable services they provide. We need to better understand what ecosystem services does the Alberta landscape supply? What are these services worth? And how can we best manage the land in order to enhance its value?
It's really hard to convey the services this land provides besides those cattle. There's biodiversity here, there's carbon capture. I mean, each one of these grass plants is a little micro dam that holds back water from coming down these slopes. All of those things we don't see in terms of ecosystem services, and we sure don't pay for them. All we pay for is the cattle. Somehow we got to balance out land uses so that the services that they provide whether those are aesthetic or cultural provisioning or regulatory, all are valued somewhat similarly.
If we want to say to landowners that we want to have this larger suite of ecosystem services like water source protection, there's no economic benefit to that landowner. There's a cost being incurred to manage the land in such a way as to produce clean water at the expense of market value services like food production.
We can grow far more food on an acre of that yellow canola out there in the background than we can on an acre of this grassland. But we can't absorb as much carbon with that acre of canola, and we probably don't function as effectively in the water cycle.
So if we want to tilt that balance and ensure we're getting a wider variety of ecosystem services being produced, the people benefiting from those management actions should be paying the cost.
The Alberta Biodiversity Monitoring Institute is working on a series of integrated projects that combine specialized ecological knowledge and expertise that can represent ecosystem service supply and demand across Alberta's landscape. When applied, the new ecosystem service knowledge can provide support for market approaches and land use planning initiatives that promote sustainable outcomes.
So what we're trying to do in this research program is develop maps and models that can tell you how much and where ecosystem services are being produced on the landscape across Alberta, where they're being produced, how much is being produced, and what the value is, where the users are of those ecosystem services.
I'm a market-driven supporter, but we have an incomplete marketplace right now. So we have some of these services that don't function in the marketplace and others that do. So if we continue on the trajectory with a partial marketplace, I think we'll end up with more Calgary floods, with more Slave Lake fires, drying out of the landscape, and probably not a very pretty place in 100 years. If we start to value these things, reward the production of some of these services through a marketplace or whatever instrument we can come up with that provides an incentive for land use that produces ecosystem services like biodiversity, carbon, water, then I think we'll rebalance things.
Alberta's grown exponentially over the last 10, 20, 30, however many years, and it's going to continue to do so in the future. So to understand and to be able to effectively make Alberta livable and maintain our standard of living for all those new people coming to Alberta, we need to be able to manage the land in such a way that it can provide those things, and this project will help provide that information.
So as was spelled out in the video, as part of this project, we are mapping and assessing the value of key ecosystem services across Alberta. The ones that we're working on right now are water purification, pollination, biodiversity, timber production, and in bold, because they're my specialty, carbon storage and forage production. And I'm going to go through just briefly what we're doing for each of these ecosystem services and basically flash a map that shows, is an example of what we've produced. But the neat thing about these models is that they're all going to be open source and available so that a group like yours could zoom in on an area that you are interested in and get information for the Red Deer watershed. And so the information I'm showing is from all of Alberta, largely because I didn't have tons of time to get the information for the Red Deer watershed, but absolutely that type of information will be available to you and open source and freely available. So water purification is probably the model that you're actually most interested in. I don't do the water purification model myself, so I'm not too familiar with the actual mechanistics behind it, but it's looking at the offloading of total suspended solids, nitrogen, and phosphorus. And so what it does is it takes all the land use and land cover information and then calculates when a water drop falls on that type of land cover and then continues its path down to a city such as Edmonton, what is the contribution from the different land types that water is flowing through to water purification in a city. And so the model's really neat because if you're looking at a city of interest, you can actually pinpoint areas and go, okay, this area was important for removing suspended solids, or this area was actually an area that needs to be targeted so that it can be improved in terms of water purification. The pollination model, this is based on really brand new science. There's not a lot known about pollinators across Alberta, and so researchers from ABMI are actually, and from the University of Alberta, are actually out this summer getting more field data so that we can populate this model. But the idea behind it is that if we map canola fields, and a lot of this information is building upon the ABMI products that Jim presented on. So when possible, we use the information we already have, and then we add more value to it. So if we have information on canola fields, and we have information on pollinator habitat, which is generally grasslands or shelter belts, and then if we put those two together so that we understand the relationship in terms of how far a bee will fly into a canola field. Because in the middle of a field, the bee may not actually be able to reach those plants, and so that may be where the farmer is depending on pollinators that he or she is bringing in. But there's actually a large component that's just from native pollinators as well. So there's a lot of math and a lot of research involved in this relationship, but in the end of it all, you can get a map of wild pollinator value per quarter section across Alberta. And so what this is showing is the value that the canola producer is receiving from having that grassland or adjacent wood, it could be forested area as well, adjacent to their fields, and the value that the bee is providing for free. Next, we have biodiversity. Jim already went over this. Obviously, ABMI has lots of information on land cover. We do tons of biodiversity monitoring. This isn't easy, but in the end of it all, we can come up with a map of biodiversity intactness or information on individual species at different areas across the province. I'm skipping timber production just because not my area of expertise in that area, and that particular model is still in development, so I didn't have any pictures for it. Carbon storage is a hard one to depict, so I've done some research on it before, and this is the kind of plot that we would use to study carbon storage. Forage production in terms of offtake for cattle. So these are the two outputs that I was producing in these models. And I'm going to go through a little bit more about the modeling that I've done just to basically give you a taste of the methods and impress on you the actual difficulty that goes into these maps that we're producing. And so for a modeling platform, I use a century model. It's an ecosystem process model, and so it represents all those relationships between temperature and precipitation and soil type, and it does it all with mathematical relationships. For my study area, I looked at the whole agricultural extent of Alberta, and then we obtained soil, climate, and land cover land data for a whole bunch of polygons, 30,000 polygons. And so when you put all this information on soil, climate, and land use into the model for 30,000 polygons, you have to leave your computer, let it run for a day or two, and then finally you get information on, it says here, run model for each soil polygon, and finally you get information on soil carbon storage and forage production across the province. And what I do generally at this point is I extract the information just for native grassland, but you could also use this approach to forecast, well, what if we took a marginal cropland and we restored it back to native grassland? What would be the increase in soil carbon and that kind of management action? And you can also ask questions, if we convert the grassland to crop, how much carbon are we losing? So here I have a map of forage production across the province. I don't have it cut to the Red Deer watershed, but you can imagine that it's kind of the inverse of that map that Jim was showing, where he showed that there were some areas of really, really high human footprint. It's It's largely the inverse for carbon storage or for forage production in rangelands, where there isn't as much footprint. That's where we have value from those ecosystem services. And then also I produce maps of soil carbon storage. And you can do a lot of math with these and get a lot of information from them. So just preliminary numbers, but soil carbon storage in the top 20 centimeters looks to be almost 1 million tons in rangeland across Alberta. And then total forage production is about 29 million kilograms. So I'm not going to put the dollar amounts on these numbers, but that's the next step for us, is to figure out, how much is this worth and what kind of trade-offs do we make when we decide to use the land in one way versus another. So what are the applications for this kind of information? Especially for a group like yours, I think there could be a lot of potential application. So one thing that we want to do is we're integrating all these ecosystem services into one model. And so we can ask, when we maximize water filtration, what kind of other ecosystem services are we losing out on? Because on some of them, there's a bit of a trade-off between the ecosystem services depending on how you use the land. We can also ask how management affects it. So I've been looking at how grazing intensity affects soil carbon and affects forage production. And climate change. In my modeling, I can directly input climate, and this is a project that we're working on right now, is trying to project how forage production, how carbon storage, and how water purification is in this project as well, how all these will change if our temperatures get higher and if our rain patterns are changing in the province. Regional planning, which is definitely one of the uses here, which we could use this information to identify the ecosystem hotspots. So either in terms of areas that we really want to focus on for conservation or management because they're so important, or areas that we want to target for improved management. And then we work really heavily on developing market approaches for enhancing ecosystem services. So this is still fairly new in Alberta, but we could think about an offsets program for ecosystem services. We're proposing projects where we look at contracts with ranchers or other landowners for providing ecosystem services. So it's a very interesting time in terms of the potential for these new projects and the recognition of the services that the land is providing. And then finally, sustainability and conservation reporting. I'm involved in a number of projects, largely with the beef industry, in terms of their reporting of biodiversity and the other ecosystem services, so that they can do a sustainability assessment of the type of management that their sector is using, and then they can use that as a benchmark into the future, or to compare across different regions in Alberta, or in whichever way that they choose. So that's it. If you want more information on our project, it's at www.ecosystemservices.abmi.ca. The video is up there as well. If you have more questions, shannon.white@ualberta.ca, or you can email anyone at ABMI. And once again, our funders and our collaborators.